Kelsey Hightower and Leon. Let's give them a big round of
I love, I'm sad Amanda's not here. I loved her presentation, it was awesome. I vehemently disagree with a lot of it, but I really loved the perspective, and that's the point. We're all gonna have very different perspectives, and it's okay. This is a point in the world that is changing, and we're all gonna have to learn how we navigate ourselves. So, Kelsey, thank you so much for doing this. I feel like we met in the last few conferences, and this is gonna be an awesome conversation. I wanna start, this is interesting because I'm usually answering the questions, so I don't need to wear glasses to read. Now I'm gonna have to do a little dual role here, so bear with me. I wanna start with, let's go back 10 years. You literally wrote this book called Kubernetes. And I wanna understand, what were you trying to teach people? Like, why do such a painstaking exercise? I mean, I went through it and it was hard, literally hard. What were you trying to teach people 10 years ago? And what are those lessons still valuable today? And is there still value in doing the work yourself to understand the underlying core principles?
Wow, what a question. If we say we were doing this for AI, we would all be like, yay, burn more tokens. Who do you think trained the models? We did. Yep. These are our ideas. They're mimicking our creativity. So when I write the docs, when I write the code, those are my experiences being committed and serialized. Yes, we have a tool that can aggregate those things and let you use them through various interfaces. But without those ideas, there is none of this. So is it worth it? When I wrote that guide, it's because I was an early contributor. Kubernetes didn't have any real documentation in terms of how everything fit together. We thought we would give people a shell script, kubeup.sh. If you ran it, you spent 30 minutes creating a random cluster, and it's like, yay, now you have Kubernetes. But if your job is to understand how infrastructure works, if your job is to wake up at 3 a.m. and troubleshoot it when it goes wrong, you can't tell the team, hey, I don't know what's going on with this shell script. And so for me, the guide was, this tool was built for the people sitting in this audience. And for me, I thought it was very important that they knew how every component fit together, so they would actually have their own model of how it worked. Because to me, Kubernetes is something that documents the previous 10 years when it came out, and most people had the experience. There's still Linux, there's still a process, they're just components that need to be configured. So yes, I think it's important that if you're gonna manage these systems, you need to know how they work. Does every developer need to know how to run Kubernetes the hard way? Absolutely not. But if you're a practitioner, it's your responsibility to make sure Kubernetes actually works. Then I think you need to understand. And the last thing I'm gonna say here is, lately there's been a lot of security tools that have been the source of vulnerabilities for companies, right? A lot of people are like, nope, I don't understand anything about security. I download this software, I outsource security to the vendor, they make the screen turn red, yellow, green. When it turns red, I do whatever it tells me until it turns green. And now the security tool is the vulnerability. And if you update it, you're hacked even more. And now there's a whole company, I won't mention their name, where no one can trust any of their deliverables right now because they don't know what to do. And a lot of people sitting in the audience have lost the ability to understand if something's secure or not. What use are you at that point? You're like, I don't know, man. Whenever they do an update, I can continue. This is the danger of any system that removes people's understanding, because when it's time to understand, you won't be able to. So to me, that's the value I've always brought to this industry. And I think there's always going to have to be a class of people who understands how things work. And if we don't exist, then I don't know if we're ready to checkpoint all of humanity right now and then hope the models do the rest. I just don't know if that's going to be the outcome.
You know, it does feel like if you let LLMs drive you entirely, it feels like you're getting dumber. Like if you don't put your hands on at least a few times, at least to understand the deep technical details all the way down to the secret level, you are losing something, and that context is super important. Kelsey, you said that eventually Kubernetes infrastructure should feel invisible to us. And if we're still talking about this in 20 years, then we've kind of failed. I remember pulling up that quote. Do you think we're making progress in that direction? Like, are we further ahead this year than we are 2 years ago, or are we kind of still spinning our wheels, pretending, and that invisibility journey is still elusive?
Yeah, we're not making very much progress. Even as a retired person, I visit lots of enterprises, and I don't blame the people using the tool. But if you take a group of people who've never designed a full product before, they always stop at the tool. They always stop at the tool. You give them Puppet, Chef, and Ansible, they make everybody in the company learn Puppet, Chef, and Ansible. You give them Terraform, they run around slinging HCL. We gave them Docker, everyone has a Docker file. It was no surprise that we gave them Kubernetes, and they're all writing YAML. It's like, what are you doing? You haven't learned the lesson. And just to understand how this is supposed to work, if you were responsible for doing all the deployments for your company, right? You said, hey, you smart people have been doing this for decades. Surely you know how to put an app on a server. Surely you know how to make sure that it stays running. It's been 20 years of the exact same activity. Why does everyone in this company need to learn how to do that at this point? Like, airlines do a pretty good job. You buy a plane ticket. Most people don't have a pilot's license. And I flew all the way here from the United States, directly here, high reliability of success. Don't know how to fly a plane, and no one even asked me to. I saw the pilot once on the way out. He said hi, and I said thank you. But when it comes to infrastructure, we don't do that. DevOps is like, oh yeah, we're gonna do DevOps. So before anyone can fly, everyone's gonna learn how to fly this 747. It's really difficult, but there's gonna be a shared, like that is the wrong interface. It's a deployment, people, seriously. Build app, package app, put app on server, IP address, send traffic, too much traffic, more apps, less traffic, less apps. 20 years we've done the same thing. So if you wanted to know how to design this API, if you're struggling with what to do instead of Helm charts or YAML files, you can literally sit next to someone and ask yourself, if I had to do everything, I can never make them run the command, what questions would you ask them? Just sit next to your colleague and say, hey, that app you're building, I will take care of it forever. What questions would you ask them? Where should it run? How much memory do you need? Or you can probably infer the memory from the traffic patterns. But you would probably ask very few questions. You say, hey, based on those 5 or 6 questions, I can totally package, deploy your app and maintain it and keep it running. And if I see something in the logs that doesn't make sense to me, I may ask you to help me make sense of this thing that I've never seen before, and together we'll make better log outputs. But then going forward, I won't need your help when I see that error message again. That process is your API. What does that thing look like? It looks less like Kubernetes. So most people I see are not doing that at all. They're still YAML and GitOps and building Rube Goldberg machines, and I'm like, wow, there could be a much better experience, but I think we're gonna have to force ourselves to get there. And I think some people hope that AI becomes this magic sauce. You can rub on your YAML files, and user experience pops out, but I got news for you that I won't share.
I love your pilot analogy. Except that when you get on the plane, the pilot still says, you know, I'm going to take you to 10,000 feet, and then I'm going to bank left, and we're going to go. I'm like, pretty much whatever it says on the ticket, as long as you get me there. I don't care how you fly the plane.
Well, I'm glad that they're coherent. I think they're letting us know that they're awake, that they're actually alive, that I feel comfortable when they actually know how high we are. So, okay, it matches the screen on the back of my headrest.
And it's 95% autopilot, right? So we just need to learn it to go. So let's talk a little bit about platform engineering. So you've been, this is the problem with writing shit out before you go on stage. If you can wing it, it's easy. So let's talk about platform engineering. So what should engineers be doing given the hype that and I know that you deliberately kind of stayed away from the hype train, and that's cool. Given today's environment, what do you think platform engineers should be doing tomorrow morning or when they get out of KubeCon to help themselves improve not only the job that they do today, but also arm themselves with the right education to get into a world where they're work is more meaningful and productive?
I mean, it's always been the same question. It's always been the same answer. Nothing changed. AI didn't change that question. You should have asked that question when you first started. How can I be better at this? And if you weren't sure, you go find someone that you thought was better at this and learn from them. The people you're there to support. As a platform engineer, your job is to make it work. That's it. The company wants to use Kafka. Does it work? No. That's your job. You download vanilla Kafka from the vendor, and it almost works the way you need it, except for not quite. You still have to configure it. You still need to authenticate your clients to it. And so there's a little bit of work. To me, so when I think about platform engineering, I only think about the gray area. It's not this fixed thing that you do. It's this gray area that's squishy. Some things just work. Like, hey, there's a SaaS thing that the HR team uses. It tends to work. They never call us. So I don't need to do platform engineering on that SaaS platform because it does what the company needs. This Kubernetes thing, this Linux thing, even this thing that I got from the cloud provider, it doesn't quite work right. And so for me, now I have to go and build that bridge between the thing I got from the provider and then the thing that I'm giving to the other side. So that's the way I think about platform engineering. So what should you do after KubeCon? Are you good at your job? Some of y'all are not actually good at your job. Like, there are some people that are not good at it. Like, seriously. Sometimes it's because you're just not feeling well. There's other things more important in your life. You just need a break. So it's hard to be good at something when there's something more important. That's a real thing humans go through. Sometimes you're not good at your job because you have 20 years of one-year experience. You're at a company where you've been doing the same thing for 20 years in a row. You're really awesome at that company. You're not that great on the market right now. And the reason why you don't know this is because you haven't interviewed in a long time. I've seen some people get laid off recently. They'll go out into the market and be like, wow, I don't have any of these skills. I was amazing where I was. I feel very inefficient now. So you need to be able to gauge where you are as a practitioner, because that is the value that you add for your career. So if you don't know where you stand in the industry, then you're not competitive. You are competing, you realize, with everyone else that is making progress. So to me, figure out what your company needs. I would be picking sessions based on, if I go to this session, well, I'll learn something new about how to leverage these tools. The other thing I think you can do as a practitioner is learn when you don't need it. I meet people all the time. Hey, Kelsey, I work at this university. We have 3 servers. They work amazingly. They never go down. I want to learn Kubernetes. Pull them to the side. So listen to me very quick. Stay away from KubeCon. Don't come back here. That's my book. Burn it. You don't need it. You don't have this problem. A good engineer knows when your company doesn't have this problem. You go back, you write a doc and say, hey, I went to KubeCon and realized we don't need anything there. And here's why. And then you dodge a big bullet. Sometimes I'm relying on the experts to just tell me the truth. Take the hype, leverage your experience, and figure out, do you need it? Now, maybe your company does need some of these AI tools. My guess is go find someone actually using it in production. Be patient. You don't need to go to every talk. Sometimes just find a person always like, hey, are you using this in production? It's like, yeah. Can I get 30 minutes with you? I have some honest questions. What breaks? When should I not use this? And I think if you keep doing those things, you'll be much better off as an engineer and realizing that you have to be competitive by really gauging yourself to the rest of the industry. Just be honest with yourself. All this stuff I see people doing on LinkedIn, I'm burning all of these tokens. I'm like, for what reason? And they can't answer the question. I'm 10 times productive. Okay, let me go to your website. It looks the same as last year. Where's the 10x productivity coming from? What the hell are y'all doing over there? Don't be that person. Just be honest.
That's pretty cool. Right tool for the right job and honest with your own skills.
Same answer and question as it always been. Nothing literally changed.
So there's a lot of hype at KubeCon this year about agentic workflows, MCP servers, and the community seems to be really excited about using Kubernetes as the substrate for these agentic workloads. Does that concern you? Does it excite you, or is that a nothing burger?
I'm excited because they're excited. To be honest, I have to step back and say, sometimes you just need some excitement. So I try not to rain on all the parades. That's just me. Be excited. Come on. But when I think about agentic workflows, a lot of us spend a lot of time making sure things work, right? If you have a tool that resets passwords, you want it to reset password only for the person that needs their password reset. This is super simple, right? Straightforward. And I watched some people show me this agentic workflow for resetting passwords. I'm like, what is it doing? I was like, I don't know. Hey, that's not my username. What is it doing? Oh, I don't know. Like, so then they put guardrails on it. I said, hey, look, I get your manager is really into agents. You know the cron directory? Etsy cron? Just name it Etsy agents. And now you have a bunch of agents running in parallel. Very low inference cost too. No tokens being burned. Highly effective too. Like guarantee you can even walk away when you hit enter. /script. Just name them agents, like reset agent, delete file agent, backup agent. You already have them. You've been writing agents for 20 years. And if anyone challenges you on this, just look at how those tools work. What do they call? They call the same tools that you've been running. Now, I do think there's a lot of value in what the agents bring to the table. Number one, discoverability problem. Not everyone knows, like everything under user local bin, you're not sure what each of those binaries do. You can try to run the man page, but sometimes the man page is just rigid reference guide. Has no really good examples on how to use this thing or what kind of output comes from this thing. So I do like the fact that the current tooling has given us a better user interface to some of these things. Using Kubernetes to run a computer program is not surprising to me, because Kubernetes still runs on top of Linux for the most part, or still runs on top of computers for the most part, that still executes the same Python and Bash scripts you've been running. None of that is surprising to me. What's surprising is that people are calling them agents, as if they're doing something fundamentally different than what we've been doing with computers for 30 years. So I'm still in the, when I see something totally different, I'm still classifying a lot of the way we use this technology as doing the same thing, either faster, but I hope people really do challenge their base level assumptions here. The fundamentals are roughly the same. This is why I think the people that know the fundamentals tend to do well with these tools. The people who are just confused are just burning tokens because it's cool to burn tokens. Remember when cloud was early, it was cool just to go to cloud? If you're a practitioner, like, why are we going to cloud? We have 7 servers. They all run Solaris. There's no Solaris in the cloud. Your manager went to the earnings call. I was like, hey, we're all moving to cloud. And it was cool. We wrote a blank check to the cloud. I know, because I used to work at a big cloud provider, and we thanked you, at least my stock options, thanked you for your contributions. Right now, we're going through the same thing with this idea around burning tokens. People are even suggesting you should be burning more tokens. But why? And in 10 years from now, there's going to be a whole conference around token economics, not crypto, but just burning AI tokens, and how people can be more efficient with using AI tokens. And I'm going to imagine some of you be like, I learned that you can just use your brain to write tools and then just execute them. So I just think we're just early on, but I just hope that pragmatists show up sooner than later.
That was a good point on economics. And you saw Kim's presentation on GPUs and cost of GPU. And I'm wondering, in your vision of the invisible Kubernetes layer, do you see the economics piece as being part of that invisibility? Or do you think FinOps always rides on top of that as a separate concern that humans have to think about?
I mean, cost has always been a thing. The world is just easier when I could just buy 100 servers, put them on-prem, amortize the cost over 5 years. I didn't have to think about it every single day. In this dynamic compute layer, then you're just one set of GPUs you didn't turn off to bankruptcy. Like, these GPUs aren't cheap, so the penalty now for being sloppy, like the cloud had a penalty for being sloppy. If you spun up a bunch of VMs, maybe your bill was double what it was on-prem. If you're sloppy with GPUs, some of y'all gotta go so we can pay this bill. The trade-off ain't the same. So I think, yes, 100%, economics are gonna probably dominate the whole GPU landscape way more than the compute landscape. You could just be lazy on the other side. This one, you can't be so willy-nilly, it's just too expensive.
Yeah, and you know, we used to have this Moore's Law, which is really straightforward, right? Like, you could plan based on compute, doubling roughly capacity every 18 months. And people are saying, including myself, I was also thinking forward on this, like, well, GPUs are gonna move even faster. So if you buy H100 last year, that ain't gonna be worth anything a year from now. But I'm kind of changing my opinion on that, because, you know, and I'll tell you why. If you ever heard the Michael Burry like slop where he shorted a bunch of like cloud providers because he said they're amortizing GPUs all wrong. I actually think A100s have a lot of use right now. Like in the world where you can't get H100s or B200s, the A100s are perfectly fine inference machines. And so their life cycle is worth more than the 3 years that they were typically amortized at. And I guess my point is, where we just had Moore's law with CPUs and memory, now we have this bi-directional decision-making process where how am I going to commit to these resources for 3 years when I don't know, none of us know what's going to happen in 3 years, right?
The reason why I feel the risk profile right now is different. Right now, we are doing the most inefficient thing possible. This is literally brute force. We're taking models and brute forcing them on top of GPUs. This is straight brute force. Typically with computing, you optimize everything to the point where you start doing hardware offloading. If you work at Google, you have TPUs that are specially designed for your training and inference. The rest of y'all are just doing brute force. So you're brute forcing on commodity hardware and paying the price. That is not how computing tends to survive. Like if you're doing HTTPS or TLS, your hardware is offloading that encryption. You ain't doing that on a regular CPU. If you try to terminate SSL on a regular CPU, your boxes will fall over. We moved that into the hardware a long time ago. We know for a fact that if you're still brute forcing GPUs and models and inference 10 years from now, you're paying a ridiculous cost. So in those economics, I think the people who make hardware, the Apples of the world, the Googles of the world, I think they went out long term because this is not sustainable. The only reason you're getting away with this is because the market is allowing this. Under normal conditions, this would be a bad sign. We spend more money than we make on a piece of technology is a bad idea. So this air cover, what, 3 to 5 more years maybe? And then when your competition is using dedicated hardware for the models that need them, you will understand the cost of optimization. So this is temporary, so I can see why people are a little nervous about buying this stuff, like early EVs. You would say, oh, my EV gets 90 miles of range. We know that is not great technology, because one day there'll be EVs that get 1,000 range. You lease them. I can see why businesses are a little hesitant right now with this current generation.
Awesome. One more thing before we take it to the room for questions. What do you think the community is getting mostly wrong right now?
That they don't have value. I meet a lot of people on the floor, they show me their cloud setup and type of app you set up. I'm like, damn, what are you doing? Right? They'll tell me, hey, the new Opus 4.6 is amazing. What about you? You gotten better? Have you gotten better since last year? Have you gotten better since I last seen you? Have you trained and tuned your own model? You know, the training that they do works for humans too. And so maybe you don't write as much code as you do. That's fine. Maybe you learn the architectural skills. Maybe you learn these other skills. That's the number one thing that I'm seeing people get wrong. They're giving all the credit to the tooling. I watched them do it with Puppet. I watched them do it with Docker. I watched them do it with Kubernetes. They keep outsourcing the value to the tool, and it's a mistake every single time. So I would hope people realize is that it's you plus the tool where the magic happens. That's the part where I think people get wrong. So if you're gonna show people how you're leveraging all these tools, show them what makes you unique about leveraging these tools. That's the part I think people get wrong, and this is where I think a lot of the anxiety comes from.
Awesome. Let's open it up for some questions.
Yep. Anyone
This
have
is
any
my
questions?
favorite part.
Yep. Just raise your hand and I'll come to you.
We have shy, introverted people in this room. I'm shocked. Someone has to break the ice.
Okay, there we go.
Just pretend I'm ChatGPT, ask me anything.
Hey, so thanks for talking. Kind of triggered with the point you made about discovery problem. I mean, first time I saw, I was using Kubernetes, it was really good at reasoning, kubectl get logs and kubectl describe. So I know I can reason with it. Just reminded me of course, with Git, because Git I can understand the state of the system of code. So it's just, to me, it's some kind of natural extension towards AI, because AI possibly, all of the concepts in Kubernetes, possibly some of the mundane stuff like, hey, I want to get to know what the pods are doing and what are the logs saying. And I think to me it looks like, yeah, most of the times or in the future, near future, we would be using AI as some kind of interface towards Kubernetes, and therefore some of the, let's say ingress control, right? That thing, I'm not sure. That is a bit difficult to automate, whatever. So my question to you is, how do you see this interface in between AI? Is it somehow we would have some kind of hybrid solution between the human, as you mentioned, the last point tool, that we use this tool, and perhaps, because that's what I did in my study, how probabilistic model could actually approach the analytical solution of the real thing, and then you could actually possibly approach with 99% of accuracy what a compiler does or a computer, I don't know.
I mean, look, so the thing that helps for me, you just don't say AI anymore. When you talk about these things, if you say AI, it's like a catch-all. It's just too big. And so everyone just gets confused. So if you just take AI out of this discussion, now let's just talk about interfaces to these systems. One thing I noticed that when I was at a cloud provider, we were very hesitant to make intent-based APIs. We just would never do it. So for example, I'll give you a clear example. If you want to make a virtual machine, in GCP, you have to call like 6 different endpoints. You have to create a network interface, attach them together, create a disk, how much storage you want, create a VM, and attach them together. Then take the results and then attach them to a VPC. That's ridiculous. That is ridiculous. Some people say, hey, maybe AI can help us. This is silly. You don't need AI for that. You just need an intent-based API. Guess what we used to call those intent-based APIs? Shell scripts. You would write a shell script that did those things. And then we would name the script the intent. Create VM. And then you gave it arguments that matched the intent. And so what I think we're learning from a lot of these tools is that they can discover these random endpoints. Remember, they've been trained. I hope people realize they've been trained. They're not looking at these things for the very first time and being like, oh, this must mean a VM. That's not what's happening. They've seen people bundle these things before. They've been trained on shell scripts that have bundled these things before. They've been trained on Terraform, the modules that I've wrote, that have bundled these things before. So of course, it's going to give you with a high degree of probability that you would like to bundle them too. So when you say create a VM with this OS, with these amount of memory, it's going to recall, and maybe it will do some nice thing around generation, but you're going to get something similar to its training set. You are. So now the question becomes, maybe it was a mistake that the industry leaned way too hard on being dogmatic about our API design, because most of us just copied and pasted it. We read one dissertation about RESTful interfaces, and we all did that and stopped thinking. We do need intent APIs, and we've been rebuilding them ever since. Configuration management is an attempt to bring intent to these raw APIs. So in Terraform, you can create a VM module. In Kubernetes, that thing we call ingress also is a aggregator of different APIs, giving you a simpler intent-based API that's declarative, so you don't have to call 7 different APIs just to point a load balancer at some containers. And so what I think a lot of these tools is doing is showing us that we did that wrong. And the reason why we didn't do intent APIs in the cloud is because we would never make everyone happy. It's like a grocery store versus a restaurant. Grocery stores sell raw ingredients. Restaurants get to make menus. But if people don't like that menu, they move on. So when you're a provider, you always stay one step below usefulness. Platform engineering fills in the gap by making intent-based APIs. So I think the value of a lot of this tooling, it gives us that missing piece. But I think in the future what you will see is people just having the courage to make intent-based APIs, a happy path, in addition to the raw path. And whether you use Cloud Code or your own brain, you will be clear on how to create a VM without calling 7 different endpoints.
Right, Kelsey. When you say the invisible way, I believe that most of the greatest technologies that people don't know about is pretty much invisible. Like Kubernetes, people don't know is we used to be the second most popular open source tool, now it's third, OpenClaw taken over. But my question is that, is the curriculum going to be rewritten? Is code going to be taught in the next 5 years? What do you think? What's your perspective on that?
every time I think about this kind of question, like sometimes when I say things like, I'm adopting this zero token architecture. And I'm like, well, zero token architecture is like, that's where I use my own brain instead of burning tokens. And people are like, how dare you think and use your own brain? Like they're like, Kelsey, you're gonna fall behind. And so when you think about when we teach programming languages, programming languages are already a very high level abstraction. Your compiler generates code too. It's been doing it for a long time. So we've been using these dialects so that a human can shorthand what they want. When I learned Ruby, I was very impressed with how the keywords lined up to a natural flow. I love Go's simplicity. And every couple of decades, we learn something more about programming, and we develop another shorthand called programming languages. LLMs right now are targeting programming languages, right? Some believe that they will target machine code, then they just become programming languages. And so if we think natural language is the best programming language, that's going to be very fun, right? Because the nuance of normal language, what are we talking, English? What dialect do we want here? Do slang count? That's going to be a weird thing, and you're going to watch. And you already see this today. I ask people to see their cloud setups, and they show me all these shortcuts and markdowns. I'm like, bro, you just created the syntax. They're like, no. I was like, yeah, look at these shortcuts you made. And most programs like 32 keywords. So will we have new programming language? That's a matter of taste and design. Well, humans, it only takes one person. Well, one person get a new idea. I saw a person that had a Go dialect that translates directly to C. Because that's the taste that they wanted to see in the world. So I hope we don't stop, because this is where creativity comes from. A lot of people struggle creating low-level things because they don't know how anything works. And the people, remember, our industry is what, 50 years old? 60, if we're being generous? Those people remember the days of writing ones and zeros and the abstractions above. And so they can see the whole machine. So when they create something new, they can see the whole machine. The people that sit at the top that have never seen below, they can only create from here up. They can't change the security model of hardware. They can't think about a different OS. They can't think about a system call. They don't even know what those do. They can't create a new hard drive architecture because they're too high at the stack. So I think we're not done with human creativity. That's my core argument. 2026 isn't the deadline for all human endeavors, all human experience. There are species we still haven't discovered yet because we are yet to go to the very depths of the ocean, to the edge of the universe. It's not over yet. This is just a checkpoint. And I don't think that means we stop thinking. I hope you won't stop thinking, even if everyone else decides to stop.
I think that there's huge value in the study of computer science at the lowest level. This is when I studied how to build compilers in school, when I studied what it's like to build an operating system from zero, what multi-threading really means, what distributed computing really means. You have people coming out of school today, and if they're only learning app development, just at the highest level, for example, they're missing that whole step. And then when it comes to instructing these non-deterministic machines how to architect your future systems, you have yourself gap knowledge in scalability or in reliability or name the core concept of computer science. So I think if we forget those lessons, it's to our peril to your point.
Hi guys. More than 20 years ago, I joined tech thanks to open source, mainly less IRC, contributed PRs, yada yada. In a world where building software is going to zero and committing a PR, it's so easy, AI slap and whatnot. So what's your perspective on how we can evolve open source communities to thrive and keep, them relevant? But also, more importantly, how we can allow newcomers to join, because it's one of the things that makes me nervous about it, because it really allowed me, and I think it would be very important that we do missing on that one.
So I joined open source because of the community, the people. So me and 2 other people started KubeCon. 3 people in a corner paid $5 for that KubeCon logo because we thought there should be a place for the people. It wasn't all about the source code. The people were also important. And I'm really excited that the conference still lives on today. So we can decide that the community continues to grow. Then the community gets together and we solve problems for each other and other humans, right? Humans still, I hope, enjoy the concept of community. The things that we gather to build Well, we can surely use AI tools if they work and they make sense. I don't think that should kill the community component of it. So to me, it's the human first community component. This AI component, again, I still regulate it as a tool that we've trained to automate things, and it may democratize people who want to contribute. So if someone wants to fix a bug on their machine, and they're using cloud code, and they can put that error message in there, and they can spit out their first patch, I think that is amazing. We want more of that to bring more people in. What I don't want to do, though, is, I've maintained an open source project, a little project called CompD. I had a vision. When I left public labs, I was thinking configuration management must change with Docker out. We don't need to be targeting servers anymore. We need to target apps directly. And as a single person creating this project, I had a particular style and taste and experience level that made CompD what it was. Just like fashion is cheap. Anyone can get cotton, silk, and whatever. But there's a difference between Prada and the thing you buy from the grocery store. Probably made from the same material, but one commands a way different price. Humans still admire taste and style and creativity. Software is no different, just a different type of material. In the case of CompD, I remember when I told the HashiCorp team, they were using CompD because you can get key values from a key value store, generate a config file. They said, hey, Kelsey, we want you to integrate Vault. I don't want to do that. This is getting carried away. It's out of scope for this project. I said, no. And they created a competitor to it, and I was totally fine with it. Even launched it, console template was the name. It came out, it went #1 on Hacker News. People were like, oh, you ripped off Kelsey. It's like, no, they didn't rip off. They've been contributing for a number of years. I said no, and this is what's supposed to happen. I've inspired this company to build a thing. That's fine. To me, that is open source. It's not about hogging all the software. So whether those people were contributing via AI coding tools or directly one by one, there's still this personality that's in these projects. Linus Torvalds and Linux, there's a personality to these projects. I don't want Golang, because of AI tooling, to try to implement every feature in the world. I like Go because it said no to a lot of functionality and features. There's still some value in having purpose-built projects. And the way I think people think about open source, which is unfortunate, if they don't have that community understanding, they think LS should just do everything that the Unix operating system does. No, LS is for listing files. Cloud Code doesn't change that. So I think we have to exercise this restraint and discipline. This is what good engineers do. They don't build things for the sake of building things. And I hope we get back to the original point. We build things for the community, and the tools we use that are secondary. This is why I hope we don't just go into AI dictates that we can build faster, so let's go and pollute every repository with random ass pull requests. That's not engineering, that's just doing stuff.
Do we have any other questions from the audience?
Yeah. Thank you for your talk. Basically, you mentioned earlier that it could be an AI bubble crash, but that's not our main focus. As an engineer, we see like daily a lot of projects which are produced or powered by AI so much in our lives that we are a little bit confused. So how much, as a systems engineer or DevOps engineers, should we invest in AI?
As much as you need to. I don't have a universal answer. I'm retired. I don't care, actually. If I'm being honest with you, I've reached economic freedom where I feel like I get to step back from this. These tools are amazing, but they're tools. You as an engineer, you will figure out where they fit for you, right? Like if it's a good use and it helps you do it, only you can judge that. Now, would I pay attention? Absolutely not. If I were you and I had to go to work every day, 100% I would be dialed in, because now I have to compete for these jobs. Right now, the industry is trending in this direction. There's no way out of this yet. And so I do think they will actually pay off. The technology as it is pretty decent. I do think people are overusing it. For example, Microsoft just put out a whole damn near blog post about how they're walking back too much AI integration in Windows. Maybe we didn't need to put it in Notepad. My bad. When I use LinkedIn, I write something there like, I hate AI. Suggest a rewrite? No, I meant that. I hate AI. I don't need LinkedIn to rewrite that post. Right, so I think we're starting to figure out when not to use it. Like, you're not really good at something until you know when not to use it. So a lot of people got excited. A A lot of people started stuffing it everywhere, and over time, a good engineer is going to know when not to use it. For example, I'm watching people run all of these agents. Literally, I do a lot of investing, so part of my due diligence, I will say, hey, you're building an agentic workflow company. That's amazing. How much does it cost to reset a password on your platform? Just want to see. Like, well, here's our cloud code cost, and if that's down, we use OpenAI. I was like, you're spending money on inference to reset a password? I was like, are you serious? Because that could be done for $0. And so it's that type of thing that a good engineer will realize that in that case, you don't need AI for that particular workflow. You still can present an agentic platform where maybe you parse a PDF using some AI tools, get the data that you need, and then call an imperative workflow where it's just Python doing the right thing over and over again. So to me, I would say invest everything, be curious. That's how my whole career was. I would never tell you not to do that. But be smart about it. Challenge everything. Ask tough questions. Side by side, when is there a better approach? When is there a cheaper approach? And when is the right approach? But only you can determine that.
This password reset must have been very recent trauma.
No, most people are 10x productive, and I'm not seeing the results. Like seriously, I'm like, hey, okay, don't show me any more cloud code. Show me something that has changed in the last year. And I'm not seeing anything. Insurance company looks the same. Website company looks the same. What has changed? And most people are literally wasting time. Like when people brought in Slack, just a bunch of communication, what has changed? This is something that I think the industry at some point is going to have to clamp down on. This is straight up irresponsible. If you're running a 100-node Kubernetes cluster and you got 3 apps on it, someone's to say, why are you doing this? If you don't, go put this in Lambda and be done with it. It's the same type of engineering rigor and discipline that I wish would apply to this particular age as well.
Yeah, it makes sense. The password trauma is still real.
Very real.
All right, we got time for one more question.
Okay.
So you said a lot about overuse of AI. Do you have any kind of guidelines for where you think it will be the most useful, where we can get the most leverage out of it today?
I mean, look, AI has been there forever. I mean, when I was at Google internally, everything was AI. The whole platform was AI. The majority was just AI. TPUs everywhere. When you use Google Maps, what do you think that is? That's AI. Some of those Gmail suggestions, spam filtering, that's been AI. You've been using artificial intelligence for a long time. I think when people see the difference between imperative programming, I remember the first time my mind made that mental leap is when I saw a regular expression. This idea that you can just take a regular expression and it has its own little machine in there that can do back propagation to find different values. And you get rid of the if, else, then case statements. And I was like, wow, that's a whole different way of doing anything. And so for a lot of people, that was a big mental leap. Most people still can't understand regular expressions. AI is a stat on steroids. Now we're taking the ability to do unstructured data and generate SQL queries again from a training set. This is not magic here. And so for a lot of these things where, for example, find the user that has spent the most money last year. Having a generative AI program that has been trained on SQL thoroughly, understands how SQL works, look at a database, and then be able to retrieve that data, that is amazing. That is a valid use of AI, where some people just want to interact with the system without learning how to do left joins. That's an amazing use of technology. I love it. Generative AI can be amazing if you just need an image for something and you have no artistic abilities. That's going to be amazing for a lot of people. I also like the way we're doing AI for just general search. It has replaced Stack Overflow for a lot of people. I just needed an example of how to do this thing. Generative AI spits out something that's roughly the same quality of what you would find on Stack Overflow. That is an amazing use of AI. The only areas where I push back is when people think it's okay to turn off your own brain when using these tools. People are bragging more than ever about, I write 10,000 lines of code a day. First of all, why the hell are you writing 10,000 lines of code a day? That makes no damn sense. Second, then you don't look at it. This is insane, folks. This is not a good idea under any circumstance. As an engineer, I think real engineers have an oath that they take, right? You have this oath to protect people with the systems you build. People literally rely on you to actually look at the stuff that you're building and be able to stand behind it. If we're getting to the point where it's like Claude did it, That's insane. That's not engineering at this point. And maybe that's what the industry wants. Maybe the industry just wants a bunch of people who are dragging and dropping ideas. And if that's the point, then we're just going to end up with a bunch of frameworks, and then people will just drag and drop and build the 10,000 Uber clones. I don't think that's what engineering is supposed to be about. So I would say use these tools as tools, and the number one tool you were born with, use your brain, and don't be afraid to.
We have one last question.
I'm in there, that's mic drop. Now we'll take the last one.
Yeah, first of all, thank you for being an inspiration for all these years. My question is, do you think that there will be a wake-up call from the current hype for AI usage? And if so, how do you think that will look like?
Usually you don't get the wake-up call until the next hype cycle comes and the attention goes away. And then you're going to have way more justification for what you're doing. So right now, you're allowed to spend all the money you want. The industry actually expects you to, right? Because we don't know what it's going to do yet. So under that umbrella, you can do whatever you want. The moment a new hype cycle comes, let's say we discover eternal life, I promise you no one's going to care about you generating and burning tokens. Seriously, it would be the bottom of the list in that regard. But until then, I would say number one, learn to ride the wave. Like it's okay sometimes to have fun. Like you sit at your desk, and you're like, this is stupid. But sometimes like just be quiet and ride the wave a little bit. Also, I would probably try to figure out what the patterns are. Because right now we're learning the patterns. In the early days of Kubernetes, we were learning the patterns. Take notes. Be the person that says, hey, from experience, this is what works, this is what doesn't work. In 5 years, you know how many companies are going to be spending 10% of their IT budget burning tokens and getting nothing from it? And they're going to be looking for people. Cast AI is going to be selling a reduce your token burn guaranteed in 5 years. If they are not acquired, they're going to have a product feature that helps you.
We already have it.
So during hype cycles, that's all I look for. All I look for are the patterns that work and don't work. And that's where your value comes from. So these hype waves are good umbrellas. So for example, if you're clever, if you're managing infrastructure right now, you know how you've been trying to order new hard drives, new network switches, and no one let you? Just say you're ordering them for AI, and no one's gonna ask you about it.
Thank you so much.